Hey, what's up? Today I'll be going through this question, finding a smallest divisor given a threshold. Okay, if you haven't subscribed to my YouTube channel, do subscribe. I'm trying to grow this channel and to make it big. Okay, so we are given an array 1, 2, 5, 9, and we want to find a smallest divisor that that when you sum up all the array, it's going to be less than 6. So the smallest divisor can be 1. So if it's 1, and let me have the sum in sum. 1 divided by 1 equals to 1, 2, 5, 9. It's the smallest divisor, but if is it lesser than a threshold? It's not. So it's 17. We want something that is less than 6. So the answer here is 5. So let's try dividing it by 5. The minimum here is going to be 1. So 1 divided by 5. Even though if it's a decimal, I'm going to return it as 1. So 1, 1, and I think here is 2. 5. So it's smaller than a threshold, so it's the minimum is 5. So the minimum divisor here is 5. Yeah, so we are trying to code this out. So as we can see here that we are given a sorted array 1, 2, 5, 9. If you are given a sorted array, we like to think about binary search. How can we use binary search to make this more efficient? So without binary search, let's say 1 to 9, you might want to start with 9, 8, 7, 6, 5, 4, 3, 2, 1. It's not going to be efficient. So we want something more efficient. So we use binary search. Let me just try and code this out so you guys can get the idea of how it works. So to have a binary search, we start with int left equals to 1, int right equals to nums back. We want to find the size of the array, int n equals to nums.size. Okay, so how do we perform a binary search? Well, left is less than right. Yeah. Let me just change this. And we want to find the mid. Int mid equals to normally we will do left plus right divided by 2. But I think it's gonna cause some issue with overflow or some negative issue. So we are going to use this instead. It works the same, but it's better. Left divide by 2. Yeah. So now we have the mid, and so the middle can be from here it's going to be 5, and we're going to test out 5. So in sum equals 0. We're going to divide 5 throughout the whole array. So 2 divided by 5, 3 divided by 5, and so on until the very end. For int I 0. Okay, so okay, we have to use double right here because we remember that if let's say the decimal is 0.01 or 0.5, it's still going to be 1, as we can see here. So 1 divided by 5 it's still going to show it as 1. So yeah, we need a double here. So equals to meet nums I divide by meet if num equals to int num. So it's something similar to testing if there's a decimal place. If there's no decimal place, we will just add it to the sum. Sum plus equals to num, I think. Okay, else if there's a decimal place, we just want to add an extra 1, additional 1. Yeah. So if the sum is greater than a threshold, it means that we have to, okay, if sum is greater than threshold, it means that the left should be equals to mid plus 1, else right equals to mid, and we want to return right. Yeah. Wait, something's wrong. I might have to record this video again. Okay, let me just check what's wrong. Okay, so I think it's here. This part, yeah. It's not giving me a double. Yep. Thanks for watching. And okay, I'm just gonna maybe try walk you through what I did, because some of you might be wondering why binary search. Yeah, we can do this without binary search, but it's not going to be efficient, because we want, if let's say there's a very big array, maybe 1 to 100, and the divisor can be anywhere in between. We don't want to like just go to 1, 2, 3, 4, 5, slowly like searching the answer. It's gonna be time limit exceeded, something like this. So binary search is to just make it more efficient. Okay, thanks for watching. See ya.